Hi everyone, my name is Zafrina binti Mama Fauzi and my ID is 5637194 and this is my experiment presentation titled Understanding the Solar System. In this activity, I used the PHYS1160 gravity and orbit simulation to explore how gravity shapes planetary motion and how changing a planet's mass, velocity or distance affects the shape and timing of its orbit. So before showing you my results, here is a quick summary of Kepler's 3 laws of planetary motion. First law, planets move around the Sun in elliptical orbits with the Sun at one focus. Second law, planets move faster when close to the Sun and slower when farther away, sweeping out equal areas in equal times. And the third law, the square of a planet's orbital period increases with the cube of its average distance from the Sun. So these laws describe how distance, speed, and orbital period are related in every planetary system. In the planet-moon setup, I observed that the planet moves slightly as the moon orbits. This happens because both objects revolve around a shared center of mass rather than the moon orbiting a fixed planet. That center of mass lies inside the planet, but off-center. In the Sun-planet system, it is deep inside the Sun, so the Sun barely moves. This difference shows how relative mass determines how much each body moves. An example of Newton's third law, where both objects pull equally on each other. In the two-scale mode, each grid line equals 1 astronomical unit, the average distance between the Earth and the Sun. This lets us model the Sun, Earth system at realistic scale. One orbit equals roughly 365 Earth days. Next, I tested 4 orbital distances, which is 0.5, 1, 1.5, and also 2 AU, and adjusted the velocity error until each orbit becomes circular. Their orbital periods were about 43 days, 170 days, 229 and also 378 Earth days. As distance increased, the orbit took longer to complete. This follows Kepler's third law. Planets farther from the Sun move slower and take longer to orbit because the Sun's gravity weakens with distance. In our solar system, Mercury has the fastest orbital speed because it is closest to the Sun, where gravity is strongest. Neptune, the most distant, moves slowest because it feels the weakest gravitational pull. This pattern matches both Kepler's and Newton's laws. Stronger gravity near the Sun means faster motion, while weaker gravity at greater distances means slower orbits. This experiment helped me visualize how gravity balances motion to create stable orbits. I saw that as adjusting mass, velocity, or distance changes orbit shape and period in predictable ways. It also showed that both the star and planet move around a common center of mass, proving that gravitational attraction is mutual, just as Newton's third law states. Overall, this activity made Kepler's and Newton's theories feel real and intuitive. In summary, my results confirm that a planet's distance, mass, and velocity work together to determine its orbit in predictable ways. The simulation clearly demonstrated Kepler's 3 laws and Newton's laws of motion, explaining how gravity governs the structure and also movement of our solar system. Thank you.